In a world of chaos and commotion, life may be more interconnected than we thought.
A network is defined as a complex interwoven structure or system. But from what we can see, life is filled with these networks from the smallest microscopic level to scales larger than humanly conceivable.
Just as interaction designer Manuel Lima said, networks are the web of life.
Let us begin with the smallest level microscopic networks. Take bacteria, for instance. The bacteria use a network to communicate. The chemical receptors in bacteria sense their environment and respond to it. One receptor sends a message through a series of enzymes and sets off a chain reaction. These receptors and enzymes work together through basic cellular communication to fit together and form a basic network. When the system discovers an antigen, anything that it doesn't recognize as part of the body's own cells, it sends a message through the network to ward off the intruder. The network structure is echoed through the neural networks of the human body. Both microscopic networks seem to relate to one another in the complexity of their structure. The human brain contains roughly 100 billion neurons, and each neuron is linked to other neurons with up to 10,000 synaptic connections.
The transportation system by which all organisms travel about the world is comprised of networks. One prominent example is the structure of our subway systems. The network is embodied through a series of routes and stations or stops. The New York subway is the most extensive subway system in the world, with 468 stations and 209 miles of track. Similarly, the Tokyo subway, although not as broad as the subway in New York City, is the most heavily traveled, transporting 8.7 million passengers daily. Likewise, ants construct tunnel systems that they use to navigate around their elaborate colonies. The Brazilian leafcutter ant constructs a remarkable network of tunnels that have been known to span 500 feet underground. Above ground, our cities are linked through a network of organized roadways. There are over 4 million miles of paved roadways in the United States alone.
Networks exist even on an enormous scale. We see striking resemblances between the nature of star maps and the maps of interlinked web pages. While the universe is constantly expanding and the amount of stars is ever increasing, the same happens with our internet. Like stars, the number of web pages rapidly increases. Our planet is intertwined with other planets to create a solar system, and our solar system is part of an interwoven celestial tapestry we call the Milky Way galaxy, which in itself is a part of an interconnected web of local galaxies, creating a network called the Virgo supercluster, which is a part of a larger network called the local supercluster, eventually creating the abstract concept of our observable universe. But humans venture to ponder the age-old question, what is beyond the universe? And since we see networks on all conceivable levels of existence, perhaps our universe is part of yet another network, perhaps a network of universes, a multiverse. A multiverse containing infinite numbers of unique universes, each independent from others, yet all held together with a force physicists call dark energy, acting just like the delicate strings of a networked web.
Networks of knowledge, networks of families, networks of mutual friends, a planet-wide network some have even called the global village. Yet the shape of each network remains the same, even the shape of a galaxy, or maybe even what lies beyond our universe. We see this web-like shape of networks repeated over and over again, everywhere. The shape of networks from migration paths of animals is the same shape as the networks of streams they drink from, and the food chain network of the other animals they come in contact with. But what network lies beyond our universe, beyond our comprehension? How big can a network reach?